Module 14 was the introduction to inflation. In Module 15, you'll learn about the market basket and the three price indices, the consumer price index, producer price index, and the GDP deflator. We learned that inflation is the rise in the overall price level, but in economics, we use the word aggregate to mean overall or total. So anytime you see aggregate price level or APL, that's going to be a measure of the overall prices in the economy. This is, of course, an average of prices. So if APL is saying that prices increased 4%, that doesn't mean that every price increased exactly 4%. It just means that on average, that's the case. So if the aggregate price level went up, we have inflation. If the aggregate price level went down, we have deflation. If you have two different levels, we could see if it's increasing less than last year, and that would tell us about disinflation. The model at the bottom here, we're seeing the difference between the price level and the inflation rate. Price levels are constantly rising, hopefully at a steady pace in America. And you've probably noticed this, that things cost more now than they did 5 years ago, than they did 10 years ago, than they did in the 1950s. That over time our prices are constantly increasing. That's the price level. The inflation rate fluctuates because it's tied to the business cycle. So when we're in an expansionary or a recovery period, the inflation rate is going up. And then a recessionary period, the inflation rate is falling. So you might have 4% inflation one year and 1% the next year. So inflation is fluctuating, but in both cases, prices are going up, and that's why price level continues to constantly rise. The market basket is a new term. This is all of the set of consumer purchases of goods and services in the economy. There's almost an unlimited amount of things that you could buy. You could buy things from other countries, you can buy things online. So it's very difficult to figure out exactly what people in America purchase. But economists do the best they can by creating a market basket of about 80,000 goods. And they measure the price of these things monthly to see how inflation is occurring. In order to do this, they have to first determine what American households buy and the approximate quantity of those goods. So, for example, how many loaves of bread does the average family buy in a year? How many gallons of gasoline does the average family buy in a year? And then they lock in that quantity because you want the only variable to be changing to be price in order to just measure inflation. Normally, when they set this market basket, they're doing it based on an urban family of four. They choose an urban family because things in the city tend to be a little bit more expensive. They react to price changes faster than in rural areas. And also in the city, you have a wider variety of goods available. They choose the family of four because that way you have different age groups, maybe boys and girls. You get a wider variety of goods than if you just measured a 20-something professional and what they purchased. So in this example here, we have a simplified economy that was just citrus. So if this family only bought citrus fruit, in a year they would buy 200 oranges, 50 grapefruit, and 100 lemons. The pre-frost and post-frost parts of this table are just to show you that you can have anything that represents year one and year two. It doesn't have to be an actual date. So you can see that we have the quantity set here at the bottom, and it's the same for both. And then the price is what's different. So we have the pre-frost prices and the post-frost prices. So 200 oranges times 20 cents plus 50 grapefruits times 60 cents plus 100 lemons times 25 cents. And then you get the cost of the market basket in the pre-frost year. We do price times quantity for the post-frost year and get the cost of that market basket, which is $175. Do you know an equation from the last module that could help you calculate the percent change between these two? Yeah, the year two minus year one. So we're going to do year two, 175, minus year one, 95, divided by year one, 95, times 100. And that would give us the percent change or the inflation rate between these two price indexes for the market basket. So you can use that same percent change equation for this new concept of a market basket. Let's do another example with a simplified economy showing only a market basket of goods available at a deli. So as you can see here, the quantity is still locked in, it doesn't change, and the price level in 2008 and 2009 are the only things that are changing. The 2008 cost of the market basket was already calculated for you. So you're going to go ahead and do 2009. So we're going to be looking at the quantity times 2009 prices. So for example, 300 times $6 equals 1,800. You should not use a calculator for this, so go ahead and practice doing the math and getting the total market basket price. Pause the video and then I'll go over the answers with you. Okay, 200 times 7 is 1,400. Now, how to multiply times 50 cents without a calculator? You could do 100 times 1 is 100, and then the 50 cents is half of 100, which is 50. So if you add 100 plus 50, you get 150. And then 500 times 250, 500 times 2 is 1,000. Half of 500 is 250. If you add 1,000 and 250, you get 1,250. Then you would total those four numbers to get the overall cost, which is $4,600. If you needed to calculate the percent change, you could do 4,600 minus 3,900, the 2008 prices, divided by 3,900 times 100, and that would give you the percent change. You've learned that inflation can be measured looking at the change in price level or price indexes from one year to the next. So here's a new equation that we're going to get that uses a base year to give us the price index. We need a base year because we want to see how has inflation changed since last year, or since 5 years ago, or since 1980. You can choose any time in the past to be the base year, and we can figure out how price levels have changed since then using this equation. So the year that you are focusing on, in this case, would be year A. The cost of the market basket in year A will be divided by the cost of the market basket in the base year times 100. So you will have the base year price index. So let's say the base year price index was 100. If the year you're looking at, the price index was 90, then the price index clearly went down. So we have deflation. Not only do we have deflation, but we have 10% deflation. And you know that because percentages are out of 100. So if you're comparing them to 100, then you must have 10% deflation in this case. We're going to go back to the original example of the citrus fruits market basket to use those numbers with our new price index equation. So first of all, we have to set the base year. In this case, the question tells you that the base year is going to be pre-frost. So we've chosen that as our base year. So if you're focusing on pre-frost and pre-frost is the base year, how would you set up the equation? It's going to be $95 on top. That's the price of the year we're looking at, divided by $95, the price of the base year, times 100. Well, any number divided by itself is always going to be 1. And so 1 times 100 will get you 100. That means that anytime it's the base year, it's going to be a price index of 100. So you don't actually have to do the math at all. That's a nice trick to help us out. For the post-frost year, where the cost of the market basket was $175, how would you set up that equation? And by the way, that one I would say is safe to use a calculator to solve for. So we have $175 on top, the cost of the year we're focusing on, divided by $95 the base year times 100 equals 184. So two things here. The first is that you don't have to use decimals when we're looking at a price index. You can just do the whole number. And the other question I get asked all the time is, what is the unit for price indices? And the answer is there isn't one. It's not in dollars, because when you have dollars divided by dollars, they cross out. They cancel each other out in the process. It's not a percentage either. It is just a number. So the first year it's 100, the second year it's 184. So following what we were learning before, what happened to inflation from pre-frost to post-frost? Do we have inflation or deflation? We have inflation, and we know how much. We have 84%, because 184 is 84% larger than 100. If you had 112 in your year two, that means 12% inflation. If you had 85% in your year two, that means 15% deflation. So you're looking at your number, you're comparing it to that 100, plus or minus, and that'll tell you inflation or deflation and the size of inflation or deflation. So our big note, the key idea, is that the price index for the base year should be 100 every time. So a little review. We now have two tricks to go with base year. If it's the price index, the base year is always 100. If it's GDP, what is the base year trick that we learned before? Nominal and real are always equal. They're always the same number if it's the base year. So those are some special things that apply for the base year in question. By the way, I had someone ask if there's real and nominal inflation. And that's going to be a no, because real and nominal, we are adjusting for inflation, and you can't adjust inflation for inflation. So that's the one thing in this unit that's not going to have any sort of nominal and real involvement. Let's do one more example with the price index equation. We have the cost of the market basket for 2008 and 2009, and the question specifies that 2008 will be our base year. So what would be the price index for 2008? It's going to be 100. It is the base year, so you shouldn't have to do any math. We should just know it's 100. If you forgot the rule, it would be $3,000 divided by $3,000 times 100. Go ahead and solve for the 2009 price index using the equation above. The price index will be 150. How we got that is $4,500 divided by $3,000 times 100 equals 150. So knowing those two values, if you skip down one more bullet on your notes, it asks you the inflation rates between 2008 and 2009. What do you think it is? It's 50%, because it increased 50% from the previous year. So it's both 50% and also 50% inflation, not 50% deflation, because prices rose. Now that we know about the market basket and how the price index can be measured, I wanted you to see that the inflation rate that we refer to is annual. So the CPI, the Consumer Price Index, is calculated monthly, but you can also average that out over 12 months to get you the annual rate. So when you hear that the inflation rate of America is 3%, that's the Consumer Price Index. We're going to see that there's Producer Price Index and other price indices, but the CPI, Consumer Price Index, sets the inflation rate that is discussed in the news. Now, you don't have to write this equation again. I didn't put it in your notes because you've already written this out in the Module 14 notes. It's just reviewing with you how inflation can be calculated, and we're looking at the price level from year 2 to year 1 divided by year 1, but we're looking at times 100, of course, but we're looking at consumer goods, the types of goods that they buy, which can be different than the type of goods that producers buy. So the only thing here that needs to go in your notes is the top section in blue. And now we're going to focus on what the inflation rate focuses on, the Consumer Price Index. The Consumer Price Index can be abbreviated to CPI. This is the most common unit of inflation. We do that because consumer spending is the biggest segment of spending in our economy. It's about 66% of our GDP comes from consumer spending. So if the prices for things that they buy go up, that's going to have a huge impact on the inflation rate of America. The CPI is computed monthly. There are people that are going into stores all over the country to determine the price of those 80,000 goods in the market basket. So even though the inflation rate we study is annual and it's nationwide, they are able to break it down further. And you can figure out the cost of living state by state. Some states are, of course, more expensive than others. Even within states, urban areas tend to be more expensive than rural areas. But we want to figure out not just are prices rising, but are there certain types of goods that are rising at a higher rate and things like that. So all that data exists, but we just put it all together and average it to figure out the cost of this huge market basket of 80,000 products. And again, you can see that the market basket they're focusing on is goods and services for that urban family of four. And then finally, just to be aware that if you see the term cost of living, that refers to CPI. So a cost of living increase is often part of people's jobs. They're called COLAs, cost of living adjustment. And sometimes that will be separate from a raise. If there's a 2% inflation rate, you would hope to get a 2% cost of living adjustment because that's not actually a raise because your real wage would be identical. It's just adjusting it to keep up with inflation. So that's kind of how cost of living works. It measures the CPI for consumers and households. Even though the CPI measures 80,000 goods and they measure them all over the country and they do it once a month, it's still never going to be perfect. And there's various reasons why. When the basket is set, they are locking in the quantity of goods. Remember, how many loaves of bread does that average urban family buy in a year? Well, first of all, not every family buys the same amount of bread. And if you're not in a household, you're not in a family, you might buy an even smaller amount. Individual spending habits won't be seen. We're looking at an average. So if you are someone that buys only organic goods or only fine dining or things like that, you might notice that your cost of living has increased more than somebody else's or more than the national average. So because we're averaging together all of these 80,000 goods, it might be different if you have very unusual spending habits. The other limitation of the CPI is the idea that sometimes things cost more because the quality of the good has improved. For example, cell phones now offer a lot more than they used to. Many years ago, cell phone plans, the monthly plan, cost much, much less. But also the cell phones offered fewer services. They didn't have data, they weren't connected to the internet, they weren't smartphones. They were just phones that you could use while you weren't at your house. So the quality has increased, and so has the price. That might look like inflation, but that doesn't actually mean inflation. It means an improvement in the quality. So that's one thing to take into account. Thankfully, when we are averaging this together with 80,000 products, it reduces the effects of things like that. But another thing to consider is if you never adjust what's included in the market basket, there will be some outdated information. Like, for example, families probably aren't buying typewriters anymore. And the amount of money that they spend on transportation, for example, might have changed. So every couple of years, they do change the quantity of the goods and the goods that they're focusing to try to keep it up to date and reflective of American families. The problem is if you change the quantity every time, Then you have two variables, price and quantity, and the goal is to focus only on price. So they want to change the market basket often enough to keep it accurate, but not too often that you can't actually isolate out the price effect alone. So they do the best job they can, but it's never going to be completely a perfect measure. The Consumer Price Index is, first and foremost, a price index. So I wanted you to see, you already wrote this price index equation on the front of the notes. Cost of market basket in year A divided by cost of market basket in base year times 100. CPI is a price index, so the equation is exactly the same. Cost and price are the same word. So my point is that you don't have to rewrite this equation if you want. It is the price index equation because it is a price index. If you'd like to write it again just for reinforcement, you certainly can, but you don't have to. Just keep in mind that if we're measuring market baskets, the main market basket is the consumer one based on those products for the urban family of four. And because it is a price index in the traditional sense, the same rule about the base year applies. For CPI, the base year will always be 100. So the CPI, the Consumer Price Index, is the most commonly used one, but it's not the only price index that we could go to. Consumers absolutely have a set market basket, but producers can often buy totally different goods than households are buying. Producers buy a lot of raw materials. They buy a lot of inputs. So we're talking about wood and steel and electricity costs and machinery and pieces of capital. So the things in the market basket for producers are going to be different, but producers have a market basket too. And that's why there's no separate equation for the PPI. You can use the same price index equation and you would just use the cost of that producer market basket divided by the cost of the producer market basket in the base year. So that absolutely functions the same way. The difference is that businesses need to respond to price changes quickly. If you are a producer of a good and all of your input costs have gone up, what are you going to do to your price? You're probably going to raise it. And you have to stay in business in a lot of cases. If all of your inputs cost 4% more and you only have a 5% profit margin, it would be silly for you not to raise your prices and keep yourself going. So when prices of raw materials go up, the PPI is going to go up to adjust that. Now let's say prices go down. You wouldn't mind if your inputs cost less, but what if all of your competitors have lowered their prices? What do you have to do to your price? You're going to have to lower it too, or else no one will buy your products. They will cost too much. So if prices go up, producers raise their prices. If prices go down amongst competitors, producers lower their prices. So no matter what's happening to inflation, the PPI will show it first. It's kind of this early litmus test that helps us see an inflation in the early stages by looking at the PPI. And that's really all you need to know. It's a pretty straightforward price index. The last price indices is the GDP deflator. This one uses the GDP totals that we've learned to see how aggregate price level has changed. The GDP can be a little bit more complicated, so we're going to start by reviewing the two different types of GDP. So we have nominal GDP and real GDP. And I'm sure you remember this price times quantity equation. When it's nominal, we're just looking at regular price times regular quantity. So if price went up, the nominal GDP goes up. If quantity goes up, the nominal GDP goes up too. So nominal GDP includes and shows us price and quantity. So we keep both of them there. Now, real GDP, if you remember, the equation is base year price times quantity. And the point of the base year is to remove the effect of price. What if prices didn't change? And all we're looking at is quantity. And that's why real GDP shows us growth, because all it shows us is the quantity of the output. Point of the story is that nominal GDP is inclusive of price and quantity, where real only shows us quantity. So let's say you take nominal and divide it by real. The quantities are going to cross out, and all you're left with is price. And that's why you're able to use two different measures of GDP, and it will give you a price index. It's going to end up with the change in price level. And that's what we want to see if we're looking at inflation. By the way, this is not the formal equation. That's on the next slide. This is just explaining how the equation works. Here we have the official equation for the GDP deflator. It's the one at the top in the box. Nominal GDP divided by real GDP times 100. And so below in the parentheses, we have what I was showing you before on the last slide and why this works. Nominal GDP includes price and quantity, whereas real, because we've adjusted it for inflation, we've taken prices out. And all we're seeing is quantity. So when you set them up in an equation like that, price times quantity divided by quantity, all you're left with is that price. So the GDP deflator uses GDP to show us price changes. So we have some pros and cons of each. The CPI, Consumer Price Index, is good because it measures the overall consumer spending. It's the most commonly used one in our economy, and it's going to tell us the cost of living. The PPI, Producer Price Index, is good because it is the most reactive to changes. It's the fastest one to respond to an inflationary or deflationary period. So it's useful because of its reaction and its speed. The GDP deflator is useful because you're not looking at any individual market baskets that only show you consumer goods or only show you producer goods. If we're looking at GDP, we're looking at all final products produced in the economy. So this should be inclusive of all prices. So all of them have a certain use. Now, my next question to you is, do you think they work similarly in terms of showing inflation? So if CPI is going up, do you think PPI will go up too? Yes, we all are living in the same economy and we all are going to experience inflation. So even though consumers and producers buy different things, first of all, there could be an overlap. For example, we all buy ink cartridges. We're all paying heating costs for our homes or for our factories and things like that. So there are some products that are universal and that, the price is going up, it affects everyone. But also, if producers have to raise their prices, that's going to be passed down to consumers. So if one's going up, the other one goes up as well. And because GDP deflator is showing all goods in the economy, if those are going up, it will absolutely be going up too. So because they all show the same inflation, they're going to move closely together. If one's going up, they're all going up. If one's going down, they're all going down. Now look at this table and which price index has the highest highs and the lowest lows. The PPI. The PPI is the red one, and you can see that its peaks and its valleys are more extreme because remember, it has to be the most reactive to changes in prices. If prices are going up, it must raise it. If prices of competitors are going down, they must lower their prices. So PPI always has the most extreme changes, and you can see that GDP deflator and CPI tend to be pretty close together for the most part. But they're all going up showing inflation, or they're all going down showing either disinflation or deflation.